all. I'm Michael Logan. I'm CEO of MP Logan & Associates. We are the global master distributor for the Smart Phases No-Cap Thermal Energy Storage and Conversion System, TESS. It is really a very amazing kind of journey. Just to kind of go back, to tell you a little bit about myself, I'm a very cause-oriented person. I was working in business in the late 1980s, and I spent 10 years in ministry working with homeless families, and we had an amazing experience seeing people get restored back in the community. And then that went away, and I had to go back in business. Well, my specialty was operations. That took me into eventually operations for engineering companies, because I was in Houston, Texas, and then it took me into specifically energy engineering, and then beyond that, took me into a role as vice president and board member for the Renewable Energy Institute for 4 years in the early 2000s. Not to blow it way out of proportion, but back then it was a bunch of guys eating sandwiches and drinking beer together and trying to figure stuff out. And we were kind of a little bit ahead of the cusp, but it was an amazing time, because I saw so many different ideas. I saw a home that would last for centuries, made from 100% natural materials, that has a 4% heat load, heat loss, that will take just about every major disaster, including fires, except maybe a direct hit by a meteorite. So I saw some amazing things, and it kept me really focused on that. And as I got into the early 2000s, or the mid-2000s, about 2015, I was contacted by Dr. Stefan Bilodeau, who is the inventor of the thermal energy storage system. Dr. Bilodeau, whose PhD is in mechanical engineering, started out in his work as an engineer overseeing engine manufacturing for General Motors. And it came to his attention that 3/4 of every gallon of gasoline is rejected heat. It's not even used to drive your car down the road. And so he began to look at, well, how can this be different? And he looked to nature. And what he found was ice. It absorbs thermal energy, and at right about 32 F, 0 degrees centigrade, it becomes liquid. And as that absorbs more thermal energy, then at 212 degrees, 100 degrees C, it becomes steam. Well, what Dr. Bilodeau has produced is a programmable, via various mixtures, environmentally benign synthetic phase change material that goes from ice to liquid to vapor wherever he programs it, from minus 40 degrees to 450 degrees Fahrenheit. So I want to show you one, because this was the heyday. This was the top of the R&D projects that Dr. Bilodeau was a part of in the generations 1 through 4 of TESS. This was the Montreal Stock Exchange Tower. And it's a 48-story building. This was done in collaboration with Johnson Controls, 2 large data centers. There are designs in here. I'm not going to get into too much of the detail, but all of this is available to you, by the way, as you correspond with us. We'll be happy to share it with you. This essentially created a very amazing opportunity, reduced the energy consumption by about 27%. And the wasted heat that was captured by the TESS unit from the back of the servers was stored as thermal energy, and could then provide 6 megawatt hours of backup power made from zero fuel electricity. Basically waste. It's like going around, I again, passionate. When I'm going down the road, I was part of Respect Big Bend over in Texas, to try to keep the dark skies so you could actually see the stars and stuff up there. And I go down the road, if I see trash, you know, it speaks to me. Actually, my grandmother speaks to me and says, Michael, Patrick, go pick up that trash. And so I stop and pick up trash, because I think that responsibility is an important thing. And if we look at where we are in the world right now, if we look at the fact that every year, in all of its forms, we spend about $6 trillion on energy. And every year, we successfully waste more than $3 trillion of that energy. Most of it is wasted as thermal energy. Let me get a drink here. So this was intriguing to me. Back in 2015, when Stefan first contacted me, the focal point began to be, how do we then take this to the next step? How do we do a global launch? And so what we've done here in the U.S. now, as of this year, we had 3 years of delays due to COVID. We had won an award from the New York State Energy Research and Development Authority. They wanted to purchase one of our units to capture the waste heat from a manufacturing process, and have some politician flip a switch and say, hey, we made this from waste heat. Actually, what I want to look at is that $3 trillion number again. I asked Stefan, what would happen, other than we wouldn't make any money, if we waved a magic wand and had TESS deployed across the world? And we can talk about various use cases, and I'm happy to discuss that in Q&A with you. But he told me this. He said, Mike, we would reduce the global raw energy consumption by about 30%. We would increase the output of every type of power generation by 25 to 40%, and we'd restore about $1 trillion a year to the global economy. Now, what that translates as is using profit to wage the climate battle. Doing something that makes sense, because it's just stupid to throw things away and just waste it and not have any purpose for it. And so what we're looking at here is an opportunity in buildings like this, which waste half to 2/3 of the energy they buy as thermal energy. I want to show you something that might catch your imagination. It sure caught mine. And I want to take some time for Q&A. This is an executive summary we just did. The bottom image that you see is a CSP trough. It's a means of capturing thermal energy. And how it does that is you're catching the heat, and at the focal point of the parabola, you have a pipe that has hot liquid in it. That hot liquid goes into the TESS unit, and it's literally a box. Inside of that box, about 85% of it are blocks of ice programmed to become semi-liquid at the specific temperature being fed to it within a 2-degree range. And what happens then is that becomes semi-liquid. We do not expand the way water ice does. So we have a completely in the energy storage, the thermal energy storage portion, there are no moving parts. All we're doing is going from ice to semi-liquid and storing the thermal energy, which if we just stored it, it would last for about 90 days. It loses about 1% a day. Now, what happens is you put it in line with the already existing systems, like they did at the stock exchange tower. And in order to accommodate the architecture, which was a little restricting, we just broke them into 100 kW boxes and put them wherever we could fit them in series in order to do two things: reduce the energy that was used in the building by managing the thermal load, and to have that backup power from the data centers. So here's how they tested it. Being pragmatic capitalists, they did this, of course, on a Saturday night. They turned off the power 6 blocks around the stock exchange tower. Less than 2 seconds, black start, backup power capacity. We had the entire building up and operational. It was like the lights flickered and they were back up again. Now let me tell you some of the things that can be done with this in combination is we have islands who buy islands of plastic that have water in it and create mountains of waste that end up in our oceans. What if we do what this trough is, by the way, used for in many cases? We use that to purify that water by making a lot of steam. That's 10 million BTUs in a day. That's a lot of hot stuff that's coming in this trough right here. And then condensing it, and instead of buying water from the mainland, islands would be able to have a water capacity, a purification capacity from either polluted or seawater. But then there's something else, and this is what excited me. You know, I love solar panels, but they're inefficient, and we can help them, by the way. I'll explain that to you after I explain how TESS works here. The second box, inside of that box, aside from the 85% that's ice, is a box that contains a liquid synthetic phase change material that is programmed to become vapor at the underlying BTUs that are stored. By the way, 3.5 million BTUs per storage per cycle and 1 megawatt output. We had that static capacity, 6 megawatt hour storage capacity is what TESS has fully charged. This then inside of it has a low pressure turbine, which then spins at the flash point of that liquid becoming vapor, which is then managed by an artificial intelligence controller, basically more high-end machine learning than actual ChatGPT stuff. But that's what manages it. That's how it integrates. How does this apply? We just talked to India. They want a license to manufacture these over there because they have a couple of huge needs. They have a very aggressive environmental posture, and they have a big problem. They have a law that's in place that says if 10 million trucks that are currently on the road don't have air conditioning in the next 2 years, they're going to come off the road. That's crippling. Okay? So we have a potential solution. We're working with them on that. They have another problem. They have 130 gigawatts of energy power generation capacity. We can help every kind, but they have one in particular that we work with, and that is coal. Coal and natural gas. What we're able to do is shrink the amount of energy that's consumed to generate the power, and then use the thermal, which is currently being pumped up and to mitigate the heat, rather than using that as fuel. We now use it as fuel, and we're able to then generate the power to push that thing over the top. We have, essentially looking at the plants, and I'm just giving you rough numbers, we can reduce the fuel consumption by about 6 to 9%, maybe a little bit more, and then increase the power output by 25%. That makes it viable a little bit longer. And that's essentially the value that we have to the fossil fuels industry. However, we help every other type. Now I want to show this to you. This was exciting to me. And then I'd like to share the opportunity and also show you this amazing technology. I had Stefan work with the engineer that is chief engineer of this solar trough manufacturer, which in Southern California, pretty much close to about where we're at in terms of solar days, enough energy can be captured and cycled through TESS to generate 18 to 20 megawatt hours of electricity in a 24-hour day with a nominal maintenance, small footprint deployment. We're talking about less than 5,000 square feet to do something that it would take solar PV hundreds or thousands of acres to do. We've been looking at a comparison 100 megawatt plant to each other. So here's what we're doing. We have, and one other thing, which we're going to be doing a capital raise on this a little bit later. We're going to take a smaller version of the trough and a 100 kW version of TESS and use that as an EV charging station. We've already been pursuing the combined use patent on that, and that will allow us to put EV charging anywhere, and even on board EV charging. That's how exciting it is. But I don't want to break away from that. I want to give you an idea of where we are and what we hope to do. What we hope to do is distribute $100 million to install these projects. We have a capital partner, OUS, which is an on-site utility company that will buy the equipment, install the equipment. The client now has two electric and 2 natural gas bills instead of the 1 or 2 that they previously had, that are smaller than what they were paying before, with no capex, no lease, no debt. That's available immediately because this needs to get out to the world. Why? Because we have a bottom line impact on both the financial statement of the business and the environment at the same time. We are, that one of the major answers, as I said earlier, we can reduce the raw energy consumption in the world by 1/3. And we can increase the capacity of existing power plants, all types, 25 to 40%, by using what is wasted. And I'm going to leave you with this because it blew me away. We spend a lot of time trying to catch light and use photovoltaics, which I thought was really cool. I was reminded today, I was walking in the doors out front, and the ones that slide open for you. I remember, okay, I'm going to tell you an old guy story now. I remember Star Trek and the captain walking toward the doors and them opening, okay, and I thought that was really exciting. So when photovoltaics came out, I was pretty excited about that. It was like magic almost. But then I saw this and I realized we've been trying to mitigate rather than utilize all of this waste heat. So what does that mean to you? What it means is we're trying to do a warm market outreach. We're looking for people who have relatives in businesses, buildings, hotels, hospitals, power plants, refineries. I just got contacted by a group that we'd worked with on a quote in Houston for a refinery there. 10 of our units will reduce their grid demand by 20%. We're already talking to Austin about investing in utilizing these across the state of Texas because it'll provide a shock absorber so that they'll be able to maintain when the hurricanes and the Arctic fronts hit. So that's how valuable this tool is, and this was the thing that blew me away. After we spend all this time trying to catch the light, there's enough heat, BTUs. I actually sat down and did the math on this. I'm like, sometimes I'll be standing at the gas pump and my mind is trying to add the numbers. Okay, I'm one of those OCD kind of people. And so one day I said, okay, how many BTUs an hour are hitting the earth? So I did the calculations. I took them by Stefan because I didn't trust me initially. Okay, math wasn't my main subject, even though it was a lot of them. I found out there's enough to power every device in every city, enough thermal energy, BTUs, that hits the earth every day to power every device in every city on the planet 44,000 times over. And we have the most underutilized, proven fusion reactor that there has ever been that's close to any of us, right at the center of our solar system. And we now have the ability to utilize that thermal energy as never before. So I'm saying this to you as you have contacts and you introduce us to someone and their business participates in what we have. They say, yeah, we'd like to have this, we'd like to have our ESG, our environmental goals met. We'd like to be able to reduce our expenses at the same time. Yes, we'd like to do that. Well, what will happen for you is you make the intro and they purchase, and here's what we do for them. Before they have to make any commitment to do anything. On our nickel, we're using what's called the Buildy app, which allows us to enter all of the billing information, the square footage, the equipment that's being used on the property, all of the stuff that we need. And with that, we'll have what's called a rough order of magnitude valuation. What is this gonna actually do? Like I said, we found a flooring factory on the East Coast that we can catch enough waste heat at the end of their process to feed $900,000 worth of electricity back into their plant that they don't have to buy from the grid. That's amazing, it's transformative, and kind of how I got here, and then I'm gonna close and give you an opportunity for Q&A. And we do have distributorships available too, for people who may be interested in that. As I look at this, what it really is, an opportunity for us to do, is to say, you know what, we can do a better job. We can stop wasting. We can stop wasting this energy. We can redeploy this energy. We can become smarter about the way we buy and spend our energy by managing this unknown quantity. It was crazy. I don't know which business it was, but I wish I could have stopped and taken pictures, but I was on the way here to get parked, and there's this business that had like steam or whatever pouring out of the vents. I don't know what was going on in there, but I almost took a picture of it. We can make that difference. We just talked to a hospital that has 22 hospitals in their chain, and we'll reduce their energy consumption by over 20%. And by catching the heat off the boiler, we'll have the capacity to provide them with backup power if something happens. And I don't know if you saw this or not, but out in California, when the storm came through, the power failed and the diesel failed in one of those hospitals. They had to put those people that were sick in an intensive care out on the streets. Our system would stop that. So that's all I have, and if you have any questions, I'd be happy to take those questions.